3, 2, 1, 0. We have commit and we have liftoff at 2:13. Saturn V building up to 7.6 million pounds of thrust, and it has cleared the tower.
Professor Hoover established the Astrobiology Research Group at Marshall Space Flight Center as part of the NASA Virtual Astrobiology Institute. He investigated microfossils and carbonaceous meteorites, and with Dr. David McRae and this is too much for me. I'm going to have you talk to them. So anyway, he's done a lot of research, okay? This is just too deep. But as you know, he's still working today, travels a good bit. I'm going to go down here. He was just recently, he's going to be on the Science Channel. You did Ancient Aliens, just History Channel, okay. Did an Ancient Aliens thing that's going to be filmed, so be watching for that. All right, let me make sure I haven't. Right, I'll finish up with this. His explorations and scientific research have been featured in films for the History Channel, Science Channel, NASA's Unexplained Files, NHK, Japan Television, National Science Foundation, BBC, Discovery Channel, and National Geographic. So, with no further ado, Professor Richard Hoover.
Thank you so much for that wonderful introduction, Heidi. There was only one major error. I didn't quit working because I really never started working. I played the whole time I was at NASA and had more fun. Everybody that knows me from that period is quite aware of the fact that it was just a tremendous joy to have an opportunity to work at such a wonderful agency as the NASA Marshall Space Flight Center. I'm talking tonight about back to the moon and beyond. What I want to tell you is how we got to the moon in the first place, and then something about how we may get back and why it is absolutely imperative that we return. One of the interesting quotes that I like very much is from Neil Armstrong. It suddenly struck me that that tiny pea, pretty and blue, was the Earth. I put my thumb and shut one eye, and my thumb blotted out the planet Earth. I didn't feel like a giant. I felt very small. And for the last several years, I've had the great pleasure and opportunity to serve as a docent at the United States Space and Rocket Center. It is indeed a privilege and pleasure to do this, and I'm very happy that I see here in the audience tonight a number of other of the docents. It's a wonderful opportunity to get to meet so many people and to share stories with them and tell them about the space program, and in fact sometimes inspire young people, and this is one of the greatest joys when you meet someone who has such tremendous enthusiasm and you know that they are going to make such a wonderful thing from their life. This is on March the 26th of this year, and along with several other docents, I had the great pleasure and opportunity to be at the Space and Rocket Center when Vice President Pence came there to chair the National Space Research Council meeting.
I believe that we are rising to meet that challenge head on. Just as the United States was the first nation to reach the moon in the 20th century, so too will we be the first nation to return astronauts to the moon in the 21st century. And I'm here on the President's behalf to tell the men and women of the Marshall Space Flight Center and the American people that at the direction of the President of the United States, it is the stated policy of this administration and the United States of America to return American astronauts to the moon within the next 5 years.
That speech was tremendously inspirational. It very much reminded me of the kind of things that I saw and felt as a young child when I watched Apollo 8 around the moon and heard the astronauts of Apollo 8 read from the book of Genesis, and when I saw the astronauts of Apollo 11 set foot on the moon, the first human beings ever to visit another body of our solar system. So now I'd like to tell you a little bit about how we got there. By way of historical introduction, it's rather interesting that Margaret von Braun chose this quote in her talk that she gave to the Marshall Retirees Association last evening. "If I have seen farther than others, it's standing on the shoulders of giants," by Sir Isaac Newton. Isaac Newton provided the laws of motion in his Philosophiae Naturalis Principia Mathematica, and in this volume he laid down the foundation of celestial mechanics and the principles of rocketry, the universal law of gravitation, which with those principles explained Kepler's laws of planetary motion. He developed a reflecting telescope and was the first one to use it to study the sun, the planets, and the moons of the solar system. So basically, all rockets are based on application of Newton's laws of motion. The beginning, one of the main pioneers of modern rocketry is from Konstantin Eduardovich Tsiolkovsky. Konstantin Tsiolkovsky derived the rocket equation. In 1883, he wrote volumes about the use of rockets to explore the cosmos. He derived the rocket equation in 1896. Then he built wind tunnels and measured different types and configurations of rockets and obtained drag coefficients. He derived the velocity for Earth orbit for a multi-stage rocket using liquid oxygen and liquid hydrogen, and calculated the escape velocity from Earth and designed rockets for the exploration of outer space. There are some very, very interesting quotes of Tsiolkovsky that I like very much. "From the moment of using rocket devices, a great new era will begin in astronomy and the epoch of more study of the firmament. Earth is the cradle of humanity, but one cannot remain in the cradle forever." And he also said, "Man will not always stay on Earth. The pursuit of light and space will lead him to penetrate the bounds of the atmosphere, timidly at first, but in the end to conquer the whole of solar space." This central image here is Tsiolkovsky crater, which was discovered by the Lunar 3 spacecraft. Robert Esnault-Pelteil is another of the pioneers of modern rocketry. He said, "I must agree with the opinion of the Germans. Even with the oxygen-hydrogen mix, a trip to the moon and back is at the limit of possibilities. The formidable realization can be only precarious and subject to the terrible hazards of a prolonged trip outside the field of gravity." In 1912, he was discussing the problems of space travel and proposed using atomic energy for travel to the moon and planets. He published L'exploration par fusée de la haute atmosphère et la possibilité des voyages interplanétaires. He devised principles of aerobraking, and he performed research on liquid and solid fuel rocket motors. In America, Robert H. Goddard was conducting research on rockets. In 1914, he patented multi-stage rockets. He patented liquid fuel rockets. He developed a tube-based rocket launcher, which was known as the bazooka when it was used in World War I. And in 1919, his seminal paper, A Method of Reaching Extreme Altitudes, was profoundly important for the further development of rocketry. In March of 1926, he launched the world's first liquid-fueled rocket. It's difficult to say what is impossible, for the dream of yesterday is the hope of today and the reality of tomorrow. Every vision is a joke until the first man accomplishes it. Once realized, it becomes commonplace. And just remember, when you think all is lost, the future remains. The great pioneer of rocketry in Germany was Hermann Julius Oberth. The rockets can be built so powerfully that they could be capable of carrying a man aloft. Oberth constructed his first rocket at the age of 14 in 1898. He did a doctoral dissertation on liquid-fueled motors for rockets, and when he submitted it with his thoughts about interplanetary space and travels by rocketry, the individuals who did the reviewing of his thesis felt it was totally fantastic and certainly not worthy of a doctorate. So he never received his PhD, and Oberth was very, very unhappy with academia after that. In fact, he said he didn't really want a PhD because he continued to make his contributions and write his volumes. The Rocket into Interplanetary Space became a profoundly important volume and was used by the subsequent people who did pioneering work in rocketry, including he inspired Max Valier, Fritz von Opel, and Rudolf Nebel and Werner von Braun. They formed the Verein für Raumschiffahrt, the Society for Space Travel in Germany, and their work was based from contacts and communications with the other pioneers, and included a great many of the workers that had visions of travel to space. I know that you believe in the future of rockets, so do I. Hence, I take the liberty of sending you a brief paper on rockets that I wrote recently. That's the audacious attitude that Werner von Braun took when he wrote a letter in 1927 to his idol, Oberth. In June of 1927, the VFR was founded in Breslau by Johannes Winkler, Max Valier, and Willy Ley. And in May 1930, Max Valier was killed in an explosion during a test of a liquid fuel rocket engine, and his assistant, Arthur Rudolph, who was very important at the Marshall Space Flight Center and the development of the Saturn program. Many of you here knew Arthur Rudolph very, very well. This young group of rocket experimenters established Raketenflugplatz near Berlin at Reinickendorf in September 27, 1930. They got this parcel of land and agreed to pay the sum of 10 Reichsmarks per year for the use of that land. And here we have Willy Ley, Klaus Reitel, Rudolf Nebel, and Edward Pendray at Raketenflugplatz. Well, this work was not always easy, and it was indeed from time to time very, very dangerous. One of the pioneers of modern rocketry was Max Valier. Max Valier did all kinds of things. He worked on the development of rockets for use in propelling cars to very, very high velocity. He worked with making rocket-powered airplanes. And here is Max Valier in his Opel automobile.
Engineer and later manager of the Saturn V project was Arthur Rudolph.
The test started off fine, but then after about 20 or 30 seconds, I found myself lying on my back. And when I finally got up, I saw that the rocket was gone, had disappeared. And only a big cloud of steam shot out of the pipes. And then I saw Max Valier waving back and forth. And so Riedel ran to him and grabbed him under his arms to steady him. But then he let go of Valier and started running towards the guardhouse. And I knew something was terribly wrong. And when I got down to Valier, because I was on the slight slope, he had already fallen down on his face. And when I turned him around, I saw that he was very badly hit by a shrapnel piece from the exploding engine. And he was bleeding profusely and was dying right there.
What had happened was a piece of shrapnel had come through the jugular vein, and Valier died to death on the floor in front of Arthur Rudolph. One of the greatest pioneers of all of modern rocketry is Werner Magnus Maximilian Freiherr von Braun. Dr. von Braun was the son of Magnus Alexander Maximilian Freiherr von Braun and Emmy Melita von Quistorp. This is a picture showing Werner von Braun and his younger brother Magnus and his older brother Sigismund. Research is what I'm doing when I don't know what I'm doing. I have learned to use the word impossible with the greatest of caution. And the other one that I like very much, we can lick gravity, but sometimes the paperwork is overwhelming. They were successful in getting a bit of land at Kummersdorf West. Von Braun said, my laboratory at Kummersdorf was one half of a concrete pit, the other half being devoted to solid propellant rockets. In December of 1934, they launched two minimum rockets, Mirax, Max and Moritz. They had a near simultaneous launch from the island of Borken in the North Sea with two regeneratively cooled LOX alcohol A2 rockets to an altitude of 2.5 kilometers. And that caused a loosening of official purse strings and plans for the A3 and instrumented rocket of advanced design. This is the A3 on the test stand. They had put in gyroscopes and accelerating and accelerometers, and that then.
With this in mind, the Army, in the person of General Dornberger, makes overtures to a 19-year-old German engineering student.
Now I was looking for people who could help us. We had one mechanic, and that was all. And I met Werner von Braun during my visits at the Flugplatz Berlin, and met him later on a car drive from a meeting in Berlin to my home. We interrupted our talk with a typical scientific remark. When I asked him how he knew about it, he said, I worked in that field. I said, okay, why don't you come to my office? Maybe I have a position for you.
Now he said we have to conduct this work behind the fence of an army post because we are interested in keeping this work secret, classified. And so he offered me one half or one old test stand in Kummersdorf to conduct this work.
It was at Kummersdorf, outside Berlin, that the first two Army-backed rockets, the A1 and the A2, were developed. It was there that the rocket engine was tested, but the actual flight had to take place here, on the island of Oi in the Baltic. The rocket in this crate is the Army's third model, the A3, with a thrust 50 times as great as any rocket we have yet seen. While there has been rocket development in other countries, under Goddard in the US, for example, military backing has now put German rocket development way ahead of the rest of the world. So the talk of getting into space is no longer a fantasy.
It's rather amusing how Werner von Braun came to get involved with Walter Dornberger. He had needed to make money when he was about 19, so he took a job driving a taxi. And he's driving his taxi when he picked up a couple of gentlemen in Army military uniforms. And they were sitting in the back seat. It was Captain Walter Dornberger and Major Ritter von Horstig. And they were sitting there talking about a problem with rocket engines. And they had a particularly thorny problem. And Werner von Braun said, "Excuse me, please, gentlemen, but I believe I can shed some light on that problem." They were a bit surprised that the taxi driver was willing to intervene on a matter which was being conducted in the most of secrecy. One of the major reasons that the Army had begun to explore rocketry was because of the Treaty of Versailles. The Treaty of Versailles, after World War I, had essentially forbidden Germany from developing any kind of significant weapons. It was completely impossible. And all of a sudden, the people in the military realized that the Treaty of Versailles didn't say anything at all about rockets, because no one would bother to use rockets for that kind of application. So as a result of that, the Army got very interested in developing rocketry, and then they became aware of the fact that there were a bunch of amateurs that were doing very, very interesting and exciting experiments.
Chef of the German Ordnance Department came to see us at Kummersdorf. And during that visit of General Becker, he was, by the way, a doctor of engineering and also a professor, he questioned us about our progress. And during the discussion he had with von Braun did not talk about the weapons we were supposed to build, but about space flights. And however, General Becker was very nice about it, but he argued with von Braun and told him, von Braun, you will never make it. You will not be able to harness the energies necessary to get you into space.
While they were at Kummersdorf, they were observed by a group of Luftwaffe officers who were first incredulous and then amazed. One of the people that came to Kummersdorf was Baron Wolfgang von Richthofen, the cousin of the famous Red Baron. They were seeking information about liquid-propelled rockets to propel a Heinkel HE-112R aircraft. And when they saw what was being done there, the Luftwaffe offered 5 million marks to build a larger facility. Well, General Becker and Colonel Horstick were quite upset about this because they were Army, and here comes Air Force trying to scoop up this wonderful project that they were developing. So they said, well, we'll give you 6 million marks on top of Richthofen's 5 million, and thus Peenemünde is born.
Should we go? It was pretty obvious that we should go to a site close to the water, because even then we were thinking of long-range rockets of the future. So it was logical to find a place from which, in relative safety and security, you could launch along a coastline where optical tracking equipment would be located. And my mother told me, why don't you also take a look at Peenemünde? My father used to shoot ducks there. Well, this is a wide area, uninhabited, but very pretty. And it was really love at first sight.
As a symbol of the Air Force's involvement, Peenemünde was not built to Army standards of construction, but to those of the for more.
Took with them to Hitler this film. It was silent and was narrated by von Braun. It showed the successful test of October 1942. It then went on to show how the rocket was tracked electronically. Following this were these scenes of pre-war Peenemünde. Finally, were superimposed the words, "We made it, after all."
The reason that was such an important test was because they had had a number of failures at Peenemünde before this flight on October the 3rd, 1942. Apparently, Dr. von Braun got into a bit of trouble because they were so elated. He said the rocket was a success. Unfortunately, the rocket landed on the wrong planet. Well, the German military didn't think it landed on the wrong planet because, of course, they wanted the rockets to be developed as a weapon of war rather than what Wernher von Braun wanted, to do peaceful exploration of outer space. The A4 V2 rocket development at Peenemünde continued to carry on very, very rapidly. It used a propellant of 3,810 kilograms of 75% liquid ethyl alcohol and 4,910 kilograms of liquid oxygen. This ultimately, as the war progressed and many V2s were being developed, this caused tremendous shortages in the potato crop because the potatoes were being used to manufacture ethyl alcohol as fuel for the V2 rockets. The warhead was 2,200 pounds of amitral, which is a mixture of TNT and ammonium nitrate. As I said, the first successful launch was October 3rd, 1942. And on June the 20th, 1944, they launched a V2 essentially vertically, and it was the first man-made object to launched into space by crossing the Kármán line. On September the 1944 to April of 1945, over 3,000 V2 rockets were launched into London, Antwerp, and Liège.
The military situation in Germany had deteriorated to the point where we could hear the Russian guns in the distance, and it was pretty obvious that we were confronted with a choice either to evacuate immediately and move west, or to wait for the Red Army to roll over.
By the time Major Tsiolkovsky, personal assistant of von Braun at Peenemünde, and later at Rockwell International.
I got a call from von Braun and left myself on the 13th of March. I was entrusted with the secret documents and other classified material and asked to hide them somewhere. For that purpose, I had to move north again. I found a suitable place in a mine, and after that had been accomplished, I returned to Blankenburg to report what I had accomplished. However, everyone had already left, including von Braun, so I had to move right on to Bavaria. Here I found an Obama in a building that was occupied by an SS detachment.
When Kepler found out that we had moved into this area, he one fine day hit upon the idea of picking out the 500 key scientists and engineers of Peenemünde and moving them to Bavaria with the pretext that they were too valuable to be captured by the Allies, but I still believe with the real idea of using us as bargaining chips to save his own life.
There were sinister-looking fellows walking around, and I found one down inside of the building. I started reporting to him, but he said, do that later. But let's talk later about that. So after he was through with his business there, we went outside and I told him where the documents were.
In the midst of all this, I was also involved in an automobile accident and broke my left arm, so I was hospitalized. It was a pretty confusing situation.
He then said, we will not stay here a while ago. We will move in with Dornberger, who has requisitioned a nice hotel in the Alps.
Wernher von Braun had received a broken arm in a very interesting way. They were terrified that they were going to be executed because the war was coming to an end. The Hitler regime was collapsing in the end of April. And they felt very strongly, because a number of SS guards had been sent to Peenemünde to protect them, that they were there also to execute them because the regime would not want this valuable technology falling into the hands of the French or the British or the Americans. So I heard from Joseph Böhm, my dear friend and colleague who went to England with me many years ago while we were developing a rocket X-ray telescope. Joseph Böhm told me several fascinating stories, one of which was that when they decided to leave Peenemünde to make this exodus, there was a great deal of confusion. In fact, von Braun said, I had 10 orders on my desk. 5 promised death by firing squad if we moved, and 5 said I'd be shot if we didn't move. Well, that gives you quite a problem. I understand that they made up a special project symbol that was stenciled or painted on many trucks. They were loaded down with rocket parts. They were with some 14 tons of documents to be kept. They were afraid they would be destroyed. Of course, Peenemünde had previously been bombed by the Allied forces, and the intention there was to kill the rocket scientists. but they had missed. They had killed a few people, but because of some errors in targeting, Dr. von Braun and all of the major of his colleagues that were the Peenemünde scientists escaped. He, in planning this escape and exodus from Peenemünde, according to Joseph Böhm, he had actually forged Heinrich Himmler's signature to the document, ordering him to take these documents and parts for a special project, feeling that if they got stopped, this letter from Himmler himself would probably be enough to keep anyone from trying to test it by disturbing Heinrich Himmler. So they were leaving at night, and he was in a vehicle driving very rapidly, and it went off an embankment down and crashed into a railroad track area, and the driver was killed, and Wernher von Braun's left clavicle and arm was broken very badly. It was set, apparently it was set poorly, because afterwards it had to be rebroken. And so in both cases it was done without anesthesia.
A man came into my hospital room and said, Dr. wants you to immediately leave the hospital here and join him up in a hotel high up in the mountains, because the Free French Army was only about an hour away from Sonthofen, was the name of the town, Sonthofen, and if you don't want to be caught by the Free French, but wait for the war to end, the American army to wind up in American hands, you better leave that place. We expected to be overrun there by the Americans, not knowing that this was the demarcation line between the French and the Americans. So after the radio had told us for several days that Germany was now overrun and the fighting had come to an end, still no one had shown up, French or American. So it was decided that Dr. von Braun's brother Magnus would be sent down to the American side and tell them where we were and that we were prepared to surrender. He went down on the bicycle, came back again the same evening, and said 4 arrangements had been made, and we all went down the next day, reported in at a border station to an American guard, and were then escorted into the small town of Reutte, where we stayed overnight, very comfortable. There was some name taking and listing and of who and what, but not too much interrogation at that point. Next morning we had breakfast, after which we emerged from the mess hall into the cool, crisp air of that alpine region to face the cameras.
There's a fascinating thing that happened. Hitler had committed suicide. It was quite concerning to all of the rocket scientists that were from Peenemünde, many of which had made their way to Haus Ingeberg in Oberjoch. And here in the Alps, they had this very, very nice ski lodge that they were living in. The owner of the ski lodge was there. They actually stayed there for a week or more. Of course, Wernher von Braun's arm was in a cast and he was healing. But then you had the Russians coming in from the east and the Americans and the French coming in from the west. And the owner of the ski lodge had a very, very large cache of extremely fine wines in the wine cellar. And one of the things that he was told was that in the French there were a number of Algerians, and the Algerians had a very bad reputation for becoming very, very mean when they got drunk. So they formed a bucket line, and they proceeded to start emptying out the wine cellar. Although by the time the bottles got to the end of the bucket line, the finer bottles usually wound up relatively empty. When they were at Haus Ingeberg on May the 2nd, Magnus von Braun, who later said that the reason he went was because he spoke the best English, and he was the youngest, but he was the least expendable of the group, because all the others were the great pioneers of rocketry, like Wernher von Braun and Ernst Stuhlinger and Walter Heusermann and many, many people, Arthur Rudolph, that all wound up at the NASA Marshall Space Flight Center and became the director, deputy director Eberhard Rees, and laboratory directors and so forth. Hermann Widener, director of Science and Engineering Directorate. So all of these people were extremely important because they had a cache of knowledge that was essentially irreplaceable. So Magnus got on a bicycle. It's interesting, we have the bicycle at the United States Space and Rocket Center, and I keep hoping that we'll get it back on display. He tied a white flag to the handlebar of the bicycle and rode down out of Haus Ingeberg to find the Americans. So the war's still going on, and he's going down a little dirt road near Schwarzwald, and an American soldier points his M1 Garand at Magnus and orders him to get off the bicycle and come forward. And he gets off, lets the bicycle drop to the ground, and walks to Private First Class Frederick Schneikert of Sheboygan, Wisconsin. And he walks up to Private Schneikert and says, "Take me to Ike." Well, Dwight David Eisenhower, Supreme Commander of Allied Forces in Europe, 5-star general. Private Schneikert didn't exactly know how to take him to Ike, but he knew that, and when Magnus told him that he was Wernher von Braun's brother and they were all up in the mountains wanting to surrender, Magnus took him back to the division, and there he was interrogated by Charles Stewart, a counterintelligence agent, and after the interrogation, they decided, well, we think you may be crazy, but if you're not crazy, you're an incredibly important asset, because, of course, the Americans had Operation Overcast, and they had been searching for the rocket scientists from Peenemünde. And now it looks like the Peenemünde rocket scientists had fallen right into their laps. So they gave Magnus a pass and authorization to come back and bring back with him a limited group of other rocket scientists. So Magnus returned. He got back there late in the evening, and they were quite worried about him by this point in time because he had been gone for quite a while. And he then told them that everything went well. And so the following morning early, they left us with a small group in their automobiles. And when they arrived, they were interrogated. There was Dr. Herbert Axter, Dieter Heutzel, Wernher von Braun, and Magnus and Hans Lindenberg, who met with the Americans at Reutte and surrendered to America and told them that these many rocket scientists wanted to come to the United States of America.
General Dornberger, Dieter Heutzel, Wernher von Braun. This is the first film taken by their new allies of those who made the V2.
They were somewhere between 300 and 400 rocket scientists that they wanted to bring, but military intelligence didn't think it would be a good idea to allow so many Germans to come in. So they told Wernher von Braun he could bring 75, and he argued that that wasn't adequate. And ultimately, about 124, some books say 127, but we suspect that maybe some of those were not actually rocket scientists. In fact, Ron Paulus thinks one of them was General Kammler. But this is the group that arrived at Fort Bliss, and you see here in this group Wernher von Braun and Gerhard Heller, Ernst Stuhlinger, Arthur Rudolph, so many of the people that many of you know very well from having worked at the NASA Marshall Space Flight Center back in the very early days of its formation. In 1952, Wernher von Braun did a series of illustrations for Colliers, and also he worked with Walt Disney in popularizing rockets. This is very interesting because this is a signed drawing on K&E paper in 1952 of a rocket configuration that von Braun had developed, and here there is an artist's drawing by Rolf Kelp, and there is the Chesley Bonestell painting of that rocket configuration. Actually, many of those Chesley Bonestell paintings were in the collection of Frederick Ira Ordway III. Fred Ordway was an assistant to Wernher von Braun, a very, very dear friend of mine. Fred and many of the Pinamunda team members would come to my home every December the 16th to celebrate Beethoven's birthday. In fact, we usually would dress up on some occasions. My wife Miriam would play the piano, and I would sing the Magic Sheep. She would give a very interesting build-up, and when it came time for my solo, I would usually come in with a very beautiful bleat, bah. It always got a laugh. In 1950, the rocket team arrived in Huntsville. Prior to that, Huntsville was known as the watercress capital of the world. And so then began the transformation of the watercress capital of the world into the space capital of the universe and the rocket city. Many of you who've been around here for a long time will recognize the Lyric Theater and this beautiful old picture of Huntsville from 1950. The Army Ordnance Missile Command was established, and here are again Ernst Stuhlinger and Wernher von Braun and Walter Heusermann. When I came to work at Marshall Space Flight, and William Mrazek over here, when I came to work at the Marshall Space Flight Center in 1966, Walter Heusermann was my first lab director, and it was indeed a pleasure to get to know such a brilliant and wonderful gentleman. General Medeiros was in charge of the Huntsville Ordnance Missile Command, and then became in charge of the ABMA. This is a 1954 image from the Project Orbiter Committee. There was a desire to have a person of Nobel laureate stature, and Ernst Stuhlinger was asked if he could help, and Ernst Stuhlinger said, yes, of course, I will talk to Dr. von Allen. Of course, here is Gerhard Heller as part of this group. That was the Project Orbiter Committee that made the crucial initial decisions about preparing the Earth satellite from the United States. In February 1956, the ABMA was formed. The Redstone Arsenal commander was General John Medeiros, and the technical director was Wernher von Braun. This is a rather interesting, this was a picture that was taken for the cover of Time magazine, and there's Hermann Oberth and Ernst Stuhlinger and Dr. von Braun and Medeiros. On the 31st of January 1958, the Juno 1 rocket launched Explorer 1. Well, of course, that was just a little while after the October launch of Sputnik 1. Prior to that, there had been a Redstone rocket launch, but there was still a competition and combat between the Air Force and the Army. Von Braun and the rocket team here were working for the Army. Well, many people didn't like the idea of second-class citizens getting the honor of launching the first Earth satellite, so the honor was to go to the Navy and to the Project Vanguard, and then when Vanguard failed, von Braun was brought in. Actually, they had a rocket launch of a Redstone prior to that, but it was inspected to make sure that there was no fuel in the upper stage. They simulated the fuel with sand, and they did not want, von Braun was told that he absolutely could not have any accidental launches of an Earth satellite. So the Redstone was shown here in August launch of 1953. Then it was developed into the Jupiter C PGM-19 using RP-1 and liquid oxygen. And there on January the 31st, 1958, you had the launch of the Jupiter C and carrying Explorer-1. The first spacecraft to escape the Earth's gravitational pull, it flew 60,000 kilometers of the lunar surface and measured radiation in translunar space. That was Pioneer 4, carried aloft on a Juno 2 vehicle, March the 3rd, 1959. In 1958, the NACA, which was the predecessor of NASA, the Special Committee on Space Technology, which was known as the Stever Committee because H. Guyford Stever was the chair of NASA, NACA, and based on recommendations of the NACA, the National Advisory Committee on Astronautics, which had been in existence since 1910, and Guyford Stever's recommendations, the Langley, Lewis, and Ames Research Centers and the von Braun rocket team at ABMA were transferred to NASA. I had the distinct honor and pleasure of spending some time with Guyford Stever while I was president of SPIE, and during the several years we would meet each year for the Council of Scientific Society Presidents meetings in Washington. This sort of is a historical summary of the dates of significant events from ARPA, AOMC, and ABMA. You had the three-stage Jupiter C in September of 56. Sputnik 1 and Sputnik 2 launched in October and November of 57. The Stever Committee in November of 58. Vanguard exploded on December the 6th, 1957, and after that explosion occurred, there was then the decision to have the Jupiter C with the fourth-stage Juno 1 launch the Explorer-1 satellite. On May, Abel and Baker were launched. In June, the ABMA project, a secret project called Project Horizon, was completed, which was a study for a lunar outpost. And in July of 59, NACA was combined and formed NASA. And then the Army, AOMC, and ABMA programs were transferred to the newly formed George C. Marshall Space Flight Center. One of the fascinating things I discovered, and if anyone's interested, I have digital copies of this, is the ABMA Project Horizon, which was concluded in June of 1959. And it was planned for a lunar outpost to be launched in late 1965. And here you see all of the various components of the lunar outpost that were to be had. They were actually to be buried for radiation protection. And the fascinating thing is it was a direct-to-the-moon flight, not a lunar orbit rendezvous, but this was the launch vehicle. This was the Nova. And it's not a piddling 363 feet like the Saturn V. This is 438 feet, 6 stages, and 50 foot in diameter with a liftoff thrust of 12 million pounds. Now, there are some of you in the audience, I'm quite sure, that worked at one time or another on Project Horizon. At the time it was being developed, it was classified. It has been subsequently declassified. One of the things that's intriguing is here's a spacesuit for an astronaut, and you had them wearing something like snowshoes, because at that time it was still thought that the regolith of the moon would be very light and fluffy, and it would be very easy for astronauts to sink down. And here you see the Saturn I and the Saturn II. And the plan was to have multiple launches of these vehicles to carry to the moon a variety of components. You had to carry the water that you were going to drink. You had to carry the fuel for return missions. You had to carry all of the tools and equipment that was going to be used. So it was going to be an enormous undertaking to actually construct a lunar outpost where ultimately it would be inhabited by 12 lunar citizens who would stay there for an extended period of time. Their report goes into great detail about the need for microbiologists to be able to keep the astronauts safe, for medical people, and of course for engineers and scientists to do lunar research and to build the structures that had to be built. When the Saturn V program was initiated, we actually were then in the plans to go to the moon. We're in a huge space race. The space pioneer in Russia was Sergei Pavlovich Korolev, and he actually had working with him a number of German rocket scientists, the rocket scientists that we wouldn't allow to come to the United States because military intelligence thought that was not a good idea. In fact, I forgot to tell you, there's an interesting story about what happened while they were in Fort Bliss. They had all just been dropped into Fort Bliss. They had been brought in with no paperwork, no documents, nothing. And Eisenhower ordered that all illegal aliens would be removed from the United States, and the people at Fort Bliss realized that, whoops, we've got a bunch of German rocket scientists here that have no paperwork. And Joseph Böhm told me a fascinating story. He was one of the people that was taken across the border into Ciudad Juarez from El Paso to a bullfight one Sunday afternoon. And he did not know what the situation was with his family back in Germany. There had been intensive bombing by the Allied forces. He had not been able to contact them. He hadn't been able to contact them while he was in Peenemünde. He hadn't been able to contact them while he was in Fort Bliss. And he was very worried about whether they were still alive or not. So they were all under strict orders not to communicate, but he had been successful in getting some stationery and an envelope and some Mexican stamps, and he wrote a letter to his wife asking about how the family was. And then when they went to the bullfight, Joseph Böhm told me that he hung back behind the others, and when they made it around a corner, he dropped his letter in a Mexican mailbox and then caught up with the group. They watched a bullfight in the afternoon, and as they came back across the border, all of their passports were stamped that they had duly immigrated into the United States of America from Mexico. So they were now official. But Böhm was terrified because he was afraid that he would be found out. And he literally had tears in his eyes when he told me that for months he was very, very frightened that he would be executed if they caught what he had done. And then he said that one day he received a letter from his sister telling him that she had received the letter he had sent to his mother. And apparently the agents had confiscated the mailbox, had removed his letter, and when they found out he was only trying to find out about his family, of course they knew where all of their family members were, they had forwarded the letter on and allowed him to receive a reply. And he said that made him have such a wonderful feeling about America and Americans, that they would allow him to know that everything was okay. And he also knew that he wasn't in trouble because they had allowed him to get this information. Well, Korolev developed the R7, the Vostok, the R7A, the Semyorka, based on LOX and kerosene, and he was in charge of launching of the Sputnik 1, the Sputnik 2, Laika, and Gagarin. Here shows the In-1 rocket that Korolev was primarily responsible for the beginnings of the development, but after he died, it was taken over by others.
Миша, ставший главным конструктором вместо Королева, принимает решение об облете Луны. Баллистики рассчитали время пуска 3 июля 23 часа 18 минут. Все ждали чуда. Старт прошел точно, но на высоте 200 метров снова отключились двигатели, и ракета плашмя упала на площадку старта вместе с 2500 тоннами керосина.
And you see a huge explosion.
Мощность взрыва составила 5000 тонн радиоактивного эквивалента. Стартовая позиция была полностью разрушена.
This was the N1L3 rocket, another launch of an N1L3. The main reason that the Russians, if they had been successful, they could have launched man to the moon before Apollo 11. But the problem was their N1L3 rockets kept exploding, and this was a significant difficulty in getting man to the moon. This is some very, very interesting footage showing an N1L3, a rather tremendous explosion occurs as well. Not a good development. Valery Mishin took over after the death of Korolev, and all 4 of the Soviet moon mission launches failed. We'll skip this. In 1960, this is the organization chart of the major members of the Marshall Space Flight Center, the major people in management. Of course, there's Dr. von Braun and his deputy, Eberhard Ries, and the lab directors are Walter Heusermann here, and Ernst Stuhlinger and Willy Mrazek. I'm sure many of you have worked with these various people. That was the German Peenemünde rocket team formed the basic management structure of the Marshall Space Flight Center. Their brilliance and their ability at managing individuals and getting people to give their best, to work very long hours because they had such amazing talent and amazing personalities, really made Marshall what it was at the very beginning. It actually was opened on the 20th of July, 1963. I think it's kind of interesting that that date is a very special date in the history of rocketry. The Marshall engineers, scientists, and managers designed, built, tested, and managed major components of the giant Saturn V rocket that carried the Apollo astronauts to the moon, and they're now developing the Space Launch System for the Artemis mission to return astronauts to the moon and explore the planet Mars. This is where the groundbreaking was done for the location of building 4200. It's kind of interesting to see this picture because 4201 and 4202 are nowhere to be seen. And of course, on July the 20th, there was the magnificent launch of Apollo 11. I'm sure most of you remember precisely where you were on those wonderful moments when Apollo 11 was launched. And here is the vehicle going through the region of maximum dynamic pressure, max Q. Such incredible power and beauty is very, very inspiring. And hopefully, before too terribly long, we will be able to enjoy those kinds of scenes again. It is a great shame that for the last several years we've had to depend upon the Russians and Russian rockets to get to the International Space Station. With the commitment that was made on March the 26th and with the responses that we've seen from industry and from NASA, I fully believe that we will in fact see future launches and landings on the moon. This shows where the lunar landing sites were. The Apollo 11 is there at Mare Tranquillitatis. These are the dates and times. Of course, July the 20th, 1969 was the date of the landing. Oceanus Procellarum is for Apollo 12. And one of the things that is interesting to note is all of the landing sites that are present here are within a relatively restricted range from about 26 degrees north to 8.9 degrees south. So everything is relatively close to the equator. The poles were completely untouched during the Apollo program. And during the Apollo program, all the samples that were brought back were considered to provide strong indication that there was no water on the moon whatsoever. Now, when the first Apollo astronauts came back, they were brought into quarantine because we didn't know whether there was any biology on the moon or not. So you had Apollo 11 astronauts in quarantine, and then the Apollo 12. This is the mobile quarantine facility at the at the United States Space and Rocket Center. And this is the biological isolation garment. When the astronauts returned, they had to, while inside the command module, change out of their spacesuits into a big, because no one knew whether there might be deadly bacteria from the moon that might do an Andromeda strain and wipe out the astronauts and everyone on Earth. So there was a great deal of concern. But then during Apollo 12, Pete Conrad went over and cut off the Surveyor 3 camera and bagged it and brought it back. And then they did an extensive biological study because the Surveyor camera had been on the moon for about 2.5 years. So the idea was that if there was any biology on the moon, the lunar dust would have carried the biology into the Surveyor camera, and when they cultured the material from the Surveyor camera, they should be able to determine whether there was any biology there. Well, on an inside lens of the Surveyor camera, after about 2.5 weeks, they were shocked that something had started growing from a small piece of foam. It was immediately sent to the CDC in Atlanta, and when they did the study, they concluded that it was Streptococcus mitis. Now, Streptococcus mitis is a common respiratory tract bacterium. While the camera was being assembled, apparently one of the people, they were taking very careful sterilization procedures and so forth, but apparently one of the people, when you talk or you cough or sneeze, you spew out lots of bacteria from the respiratory tract, and one of the common ones is Streptococcus mitis, which is a normal, ordinary bacterium that's perfectly harmless. It's in every human body, and it's not the bad Streptococcus like gives you strep throat. But apparently one of the people assembling the camera had coughed or sneezed, maybe his mask came loose or whatever, and here this bacterium landed there, and the exciting thing is it stayed alive on the surface of the moon with the high temperature, the low temperature, the radiation environment, and the hard vacuum for 2.5 years. The fact that it started growing only after a slow period, about a week and a half, proved it was in a spore state, and the fact that it was only one species proved that it was in fact indigenous and had survived on the moon. Well, I talked about that. NASA wrote stories about it. And then John Rummel came along in 2011 and says, no, this is all wrong. We've solved this mystery. It was actually caused by the people working on the camera without proper procedures and techniques and forgetting basic biology 101. Well, that was totally false. And John Rummel knew it was false because John was a microbiologist. And he knew that if they had contaminated the camera after it came back, then it would have had a whole host of microorganisms that would have started to grow immediately. But for some reason, it was propagated, and it's still propagated continually, that this was contaminated after it returned from the moon. Part of the reason is probably because John Rummel was planetary protection officer, and the fact that we had brought a terrestrial bacteria and left it on the surface of the moon was something that he was not terribly happy with that idea. So, I want to then tell you, I came to work at NASA in 1966. I want to tell you about my own personal reflections from work at NASA. I started in the optics branch of the Applied Research Division in February 26th of 1966. And my first job was to test this primary mirror, the 21-inch primary mirror that had been installed in the telescope, the main telescope of the Rocket City Astronomical Association. And the telescope, the dome itself had been made by Wilhelm Angeli and Werner von Braun and Ernst Stuhlinger, as we see in that image. One of the things that I was told to do when I first came to Marshall was to make a paraboloidal mirror to a 20th of a wave. My boss, Jim Taylor, said if you're going to work in optics, you need to understand how optics are made. So he gave me that task. And while I was preparing this presentation, I discovered something very fascinating. In 1929, von Braun was given a similar task. He had taken a job at a locomotive company, a locomotive factory, and his boss gave him a sort of a lumpy sphere of steel about the size of a baby's head, he said, and told him that he was to make for him a cube, and he handed him a file. So von Braun proceeded to describe how he started filing this baby's head sized sphere of steel, and he filed and he filed, and he pointed out that on each of the 4 corners you've got to have every face has to be flat, and every corner has to have 3 angles that are 90.000 degrees. And when you have that condition satisfied and all of the sides are exactly the same length, you have yourself a cube. Well, he reported that he worked on his cube for several months, and finally, at the end of several months, when he completed his cube, he went and handed his boss a steel cube the size of a walnut. This is my late wife, Miriam, and we got to become very good friends with Ernst Stuhlinger and with Walter Horseman. As I said, they came to our annual Beethoven birthday parties, and this is a picture of me at the Apollo 17 launch. I went to most of the launches with Fred Ordway, and Fred and I, and Fred Singer, and Diane von Furstenberg, and several others were having lunch at the Orlando on the day of the Apollo 17 launch, and we hear this booming voice, "Well, this is an interesting group. You mind if I join you?" And we looked up, and it was Werner von Braun. And he sat down and chatted with us for about an hour and had a piece of pie while his handlers were going a bit crazy because they really wanted him out at the Cape rather than sitting there at the Holiday Inn in Orlando. And then we hear this whoop, 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 and a helicopter landed on the grass of the Holiday Inn, and he and Everhard Reese went out and got in the helicopter and flew off, and we had to pile into my car and drive, so it took us quite a lot longer to get there. One of the other things that I started working on was corner cube reflectors for the Apollo missions. We were planning to do lunar laser ranging and communications. And actually there were corner reflectors that were put on Apollo 8, but then General Sinclair decided that everything that wasn't essential had to be taken off. So the corner reflectors were taken off, but then Professor Dickey at the University of Maryland was able to convince them to carry an array, a 10 by 10 array of corner cube reflectors on Apollo 11. And they were put there. It was believed that they would only last for a couple of years until the moon dust caused them to cease to work. And that wasn't correct. They are still working, and they're being studied by using laser beams sent out by the Apache Point Observatory Lunar Laser Ranging Operation, Apollo. They send picosecond pulses of laser light, and they're able to measure the precise distance from the site of the Apache telescope to the corner reflectors on the moon to a precision of 1 millimeter accuracy, and that's made it possible to verify that the universal constant of gravitation has not varied by more than 1 part in 10 to the 12th, and that the Einstein equivalence principle is valid, showing that the general relativity is actually a more accurate representation of gravitation than superstring theory. One of the other things that we did is we built the Multispectral Solar Telescope Array, which was launched in 1991 by a Terrier-boosted Black Brant. This was an array of multilayer telescopes, and each one took an image of the sun in a different spectral wavelength. A multilayer telescope is made by making the surface of the mirror extremely smooth, a few angstroms RMS, and then coating it with alternate layers of a high atomic number, a high Z material, and a low Z material. And when you build up 50 or 100 layer pairs of high density material and low density material, and they're exactly the same thickness, then you can make a synthetic Bragg crystal on a curved surface. And so we obtained the first X-ray telescope images with multilayer optics. That was done on a sounding rocket flight with Professor Walker. At NASA, one of my first major projects was Skylab ATM experiment SO56. I became co-investigator with James Milligan and Jim Underwood, and we took 25,000 X-ray pictures of the sun from Skylab. I also had the job of cleaning our telescope after it was contaminated. They got the mirrors contaminated because it was repressurized. The vacuum chamber was repressurized with Houston air, and a big cloud formed, and it snowed on the telescope mirrors. They didn't want to let us re-clean it, but when Jim Milligan sent a letter to the administrator telling him he wouldn't take responsibility for the quality of the images, we got permission to re-clean the mirrors. I was using pure alcohol on little strips of high-quality diaper cloth that had been carefully boiled in a clean room to remove the sizing, and I would work for about 15 minutes or 20 minutes, and then because of the ethyl alcohol fumes, I would start getting drunk and decided that I had to get back down. Drinking on the job is never a good idea. The US-UK Rocket X-ray Spectroscopy Telescope, we flew from South Australia and got the spectra of the Puppis A supernova remnant. And then we used the mirrors the multilayer mirrors, and got the cover of Science with this image that was produced by that telescope, and then simultaneous images, as I showed previously, with MISTA. In 1997, we established the Astrobiology group at the NASA Marshall Space Flight Center. I was co-investigator with Ken Nielsen of NASA JPL. That was to study microbial extremophiles. And I went in and told my boss that I was invited by the Russians to go to the Kolyma lowlands of far northeast Siberia. Would he approve my travel to go to Siberia? And John Davis looked at me and he said, "Sure, if I can buy you a one-way ticket." I said, "Okay," and I ran out of the room because I didn't think NASA would let him buy me a one-way ticket. We have subsequently discovered one new family and 5 new genera, 15 new species of bacteria and archaea from these expeditions. I've also was working with David McKay, who was very well known for the discovery of possible life on Mars in the Allen Hills meteorite. He formed the Astrobiology Center for Biomarkers in Astromaterials, and I was co-investigator with David McKay in that virtual institute. And I have subsequently been working with Greg German using scanning electron microscopy and with scientists at the Joint Institute for Nuclear Research in Dubna. These are microfossils of cyanobacteria in the Argay carbonaceous meteorite. And these are diatoms that we discovered last year and published in December. These are single-celled algae plants that build these beautiful shells of silica. And just last week, my colleagues that are working with me there, working on their doctorate, sent me new images of diatoms that they had just found. Diatoms are very rare in the meteorite, but they are present. When I was in the Fox Tunnel of Alaska and in Siberia, I found mosses. This is a moss from the Fox Tunnel of Alaska that's living and growing after having been frozen for about 32,000 years. We also described this new organism we called Carnobacterium pleistocinium. These are images of Carnobacterium pleistocinium. This is the first living Pleistocene organism that has been revived on Earth. I worked with Sabita Buizov to study microorganisms in the deep ice just above Lake Vostok. We found very interesting things. This is Sabita Buizov. When he wanted to search for microorganisms in the deep Vostok ice, Imshinetsky is his director of the Institute of Microbiology. Sabit kept pestering him, so he decided, okay, I'll get rid of him. I'll send him to Vostok Station, Antarctica. And Sabit is he is the only human being ever to have wintered over at Vostok Station on 3 separate occasions. And the temperature at Vostok can get to minus 85, minus 90 Celsius, and with winds of 80 to 100 miles an hour. So it's one of the most dangerous places on Earth because if you go outside, of course, during the winter, it's continually night. It's very easy to freeze and die at this drilling station. These are diatoms from 2,827 meters beneath the surface of the ice at Lake Vostok that we discovered at Marshall Space Flight Center in the scanning electron microscope there. One of the fascinating things is that life exists in ice. It is present in ice and it remains frozen in ice and can be cryopreserved. For that reason, it is very, very important that we go back to the moon, to the craters at the south pole of the moon. This is in Alaska. This is in the Schermacher Oasis of Antarctica. That's the Kverkubet Glacier, the ice cave in Vietnamkul Icecap of Iceland. That's in the high Alps of Switzerland. And this is me and Owen Garriott and Jim Lovell at the South Pole. I had my hand around this pole that is driven, a steel pole is driven into the South Pole every January the 1st. And every January the 1st, the next year you have to put in another one because the ice has moved and the pole is about 100 meters away. So when you look that way, you see one after the other going all the way back to IGY of 1957. So I'm there. I have my hand around the south pole of the planet Earth. I called home and my wife answered the phone. I said, "Miriam, you'll never guess where I am." She says, "Where?" I said, "I'm at the south pole of the planet Earth." She says, "That's nice. I bought a horse." You can't impress her. And there wasn't anything I could do about her buying a horse. I was out of touch. This is a new organism that we described last December, or actually published last December, William Whitmani at Derive. Dr. Pakuta, who did the isolation and characterization. These are long, slender things with little round tops. They look like dandelions. And we wanted to call it William Whitmania after our friend and colleague William Whitman. It's a new genus, new species, and new family. And we wanted to call it William Whitmania dandelioni. But the sticks in the mud at the journal wouldn't let us name it dandelioni. We had to name it Latin. So we decided to call it Theracassi, which is the Latin name for dandelions. There's always more than one way to skin a cat. One of the fascinating things is that these organisms contain very, very intricate structures for gliding motility. And those same kind of structures and the same genes for gliding motility are found in this is Floridia Zaire Ebola virus. It contains the gliding motility structures that we called antii. The antii have also been discovered in the HIV virus, in a wide number of bacteria like Helicobacter pylori. And while I was in Russia last July, I was watching a video that was being shown by people from Tescan that make the Tescan Vega scanning electron microscope. And I saw these antii swim, allowing these cells to swim and move. I called Elena Picudo on the phone and said, "You'll never guess what I just saw." She said, "What?" I said, "I saw antii." She said, "Richard, we see antii all the time." I said, "Yes, but we don't see them in cancer cells all the time." These were antii in the Henrietta Lack strain, the Gila cancer cells. Henrietta Lack was the black lady who died many, many years ago, and there's more biomass in Henrietta Lack and Gila cancer cells than Henrietta Lack was when she was alive by many, many orders of magnitude. And she had made profoundly important contributions to science and medicine by the fact that her cells continue to remain alive, and she has in fact essentially become immortal. Well, Dr. Pakuta went immediately to University of Georgia in just outside of Atlanta and got the Gila strain of cancer cells and brought them back and verified that they do indeed have antii, and also they have the gene for the type of gliding motility that is characteristic of antii. This is the Minos Linnea region of Europa. Here is when we went to Antarctica in the 2008 expedition. We drilled through 10 meters of ice, and Dale Anderson dove through the ice and took these photographs of stromatolites, and you notice this intense red color. I took this sample of Schlamminomonas nivalis from Lake Yakutsk in the Kolyma lowlands. In fact, I almost died taking this sample because I would go every day to collect my samples of red snow algae. And after I'd been doing this, this was on a snowbank it was in September the 10th of 1999, and this snowbank was slowly melting. But the red snow algae were there, and so I kept going every day. And one day I wasn't paying attention. I was collecting nice little flowers and nice little lichens and liverworts and mosses. And all of a sudden I get to an area where there's big barren ground. And in these huge denuded areas of the ground, then I noticed that there were a couple of leg bones of caribou. And then there was a big hole in the ground. I thought, what in the world happened here? Oh, that's the wolf's den. I'm walking through the front door of the wolves. There was a male and female and 3 cubs that would sit up on the top of the hill and watch us drill. And then I decided, maybe not a good idea. I had nothing in the form of a weapon. I had some collecting bags, but they probably wouldn't have been much help. Cassini mission found water ice geysers from tiger stripes at the south pole of Enceladus. And the gravity data indicated a vast regional subsurface sea of liquid water at a depth of 30 to 40 kilometers up to 50 degrees south latitude. Well, as I said, on March the 26th, Vice President Pence committed to landing American astronauts at the South Pole of the Moon by 2024. He stated that we were going to land American astronauts on American rockets launched from American soil, and that it would carry the first female astronaut to the surface of the moon. This caused tremendous excitement. It caused NASA to rename the SLS program the Artemis program in honor of Artemis, sister of Apollo. And the thing that is so exciting to me is it's been known for several years that there is evidence for water ice in Shackleton and several other craters at the lunar South Pole. There's also evidence of water ice in the North Pole. The reason the water ice is so exciting is because the water can be broken down into hydrogen and oxygen. This gives you liquid hydrogen and liquid oxygen if you use regenerative cooling. So basically, the South Pole of the Moon is full of rocket fuel, but it's also full of liquid, which can be consumed as drinkable water, so you don't have to carry water. And when you break it down, you get oxygen, which you can breathe. You can then use the hydrogen to liberate more oxygen from hydroxides in the lunar rocks, and it may contain extraterrestrial life forms. On March the 20th, Chandrayaan Minisar discovered more than 40 permanently darkened craters near the moon's north pole, and those craters are estimated to contain 600 million tons of water ice. Cassini flew to Enceladus, and this is a very beautiful rendition of Enceladus with the geysers that are spewing out of Enceladus. This was prepared by David Weigel of the USSRC Planetarium. If you haven't been to a planetarium show, you should go. They're really absolutely spectacular. When you see this on the magnificent screen, it is really, truly amazing. Here is a better view of a different area. There are these cracks in the ice of Europa and of Enceladus, and they're called the tiger stripes. And now it is well known that they are pulsing out streams of water vapor and water ice crystals. This is the Cassini Spacecraft, and one of the exciting things about Cassini is during the latter stages of its life, it was put into an orbit where it would traverse Enceladus and go around and come in very, very close to Enceladus. And if it hasn't given up on me, yes, there it goes. What they did is by configuring the orbit that they chose, the Cassini spacecraft actually flew through the water plumes coming out of the tiger stripes of Enceladus, so it was able to taste the materials that were coming out, in effect, by using its spectrometers, and it was able to determine that absolutely this is H2O, but also there are a wide variety of organics in that water. So the ocean underneath the crust of Enceladus may contain living organisms. And one of the things that is very, very exciting, I can tell you that all of the oceans that are deep oceans everywhere in the universe are all alike. And that is an amazing thing to say. But the reason that I can make that statement is because water has a maximum density, if it is fresh water, at minus 3.4 degrees Celsius, like Lake Vostok and Lake Michigan and so forth. When you go deep in the lake, the water is going to be plus 3.4 degrees centigrade. If it is salt water, the deep oceans, the temperature is minus 3 degrees centigrade. And it doesn't matter if it's an ocean under the North Pole where the temperature above may be 50 degrees below zero. in the deep layers of the water, since if you take a set of liquids of different densities, the highest density liquid will always sink to the bottom, and water is at its highest density if it's salt water at -3°C. So that means the oceans under the ice crust of Europa or Enceladus or Pluto, the deep water oceans are going to be at -3°C if it's salt water, or +3.4°C if it's fresh water. So if you were to take microorganisms or even larger organisms from the planet Earth and punch them through the crust of Europa or Enceladus and drop them into that water, they would probably consider it a very, very hospitable place, a very habitable place, and think of it as home. Which means that all of these people that are saying you've got to find Earth-like planets in order to search for life, it's nonsense. There can be life on the icy moons of Saturn or Pluto or Neptune or Jupiter or any of the other distant star systems of our universe. This is the North Polar ice cap of Mars, and here is the South Polar ice cap of Mars. And Mars' polar cap is very, very exciting because it is primarily frozen H2O. It's about 3 kilometers thick and about 1,200 kilometers in diameter. It contains of the order of 1.2 million cubic kilometers of water ice. And in the wintertime, it gets cold enough at the polar ice cap of Mars for carbon dioxide to condense out of the atmosphere and form a covering, typically of the order of 3 to 10 meters in thick. So you've got 3,000 or 3,400 meters of frozen H2O, and it gets covered over by a thin layer of frozen carbon dioxide. Many people are of the belief that the ice caps of Mars are in fact carbon dioxide. That's totally false. You have a carbon dioxide envelope in the winter, but during the summer it is CO2. Now the reason that that frozen ice cap in the winter is still nice is because when you fly vehicles like SpaceX and so forth, the Merlin engines and several of the other engines that are being developed for the SpaceX programs don't use liquid hydrogen and liquid oxygen, but use liquid methane and liquid oxygen. And there are mechanisms whereby using a catalyst you can convert carbon dioxide and water into methane. So with the dry ice at the surface of the ice cap of Mars, you can make fuel that would be perfectly suitable for SpaceX type engines as they're currently using, or would be suitable for J2 or J2S or any of the other liquid hydrogen, liquid oxygen engines that have been so important for the space program for the Saturn vehicles. On April the 17th, I was invited to go to the Whistler Ice Cave. This guy some of you may recognize with the crazy hair, that's Giorgio. I was a bit embarrassed when they told me that Giorgio hadn't arrived yet. I asked, who is Giorgio? And they told me he's the star of the show. I thought I was going to be the star of the show. And Ron Paulus had to tease me about the blonde. I said, leave her alone, that's my hair and makeup lady. Every time they would stop, she would powder my nose and make sure that my hair was combed properly. I decided, yeah, you can get used to that. This is the ice cave, the Whistler Ice Cave, one of the most beautiful places on Earth. And those are microorganisms, protozoans, algae. We have diatoms, we have all of those protists, these are diatoms, and these are algae, cyanobacteria, and those protozoans are running around feeding on the algae. This is another image. This guy looks kind of like Groucho Marx. And you see all these green blobs up here. Those are green algae, and just like some of the bigger particles and tiny moons of Saturn clear out spaces and form the spaces between the rings, he's obviously been clearing out a lot of the algae that he's gobbling on. So this whole area down here is free of algae, and the other area still has plenty. But he'll get it sooner or later. Well, actually, probably not, because I think he dried out on my slide. I didn't mean to kill him, but for science, sometimes you have to do things. This is ice worms. These are ice worms, I should say. Look how they're wiggling around. They're coming out of the ice. You see some down here deeply buried in the ice, and those others are wiggling around. They're very, very tiny, very unusual. This is the Pemberton Glacier here up at the top surface. I collected ice worms in the Whistler Ice Cave, and they are most intriguing because they live and grow in ice. They come out only at sunset or right before sunrise. They don't like the sunlight. They eat algae and diatoms and protozoans and so forth. And they're perfectly harmless. If you get them above 5 degrees centigrade, they die. If you put ice worms in your hand, they are totally destroyed. They turn into jello because the proteins are destroyed by the extremely hot temperature of the human body. Well, NASA's preparing the Block 1 of the space exploration mission. It hasn't launched yet, so this is a digital rendition of what it should look like when it does launch. We're very excited to see the SLS launch, and the people at Marshall Space Flight Center are working very, very hard since the announcement of Vice President Pence to make this happen. So the plan is to the moon and then on to Mars for the SLS Artemis mission. This is the SpaceX system for plans. This is a Falcon Heavy rocket. Beautiful launch. And Elon Musk always has been a dreamer, and now then he's talking about the BFR, the SpaceX gigantic rocket, which is hopefully going to make great strides. You wake up in the morning and think the future is going to be great, and that's what being a spacefaring civilization is all about. It's about believing in the future and thinking the future will be better than the past. Here is Elon Musk describing the BFR.
Well, surface of Mars, maybe Ceres, but if you have a propellant depot on Mars, you always get
very unusual design. But you see they have a lot of impressive hardware here as well.
All the way to the outer solar system. So BFR is really intended as an interplanetary transport system that's capable of getting from Earth to anywhere in the solar system as you establish propellant depots along the way.
Of course, you don't need propellant depots if you can fill up at the north or south pole of the moon.
Yeah. So we've increased the payload section to be over 1,000 cubic meters. I think it'll probably end up being something around 1,100 cubic meters. There are forward actuated fins and rear actuated fins. The way that BFR flies is somewhat counterintuitive. If you apply the sort of normal intuition, it will not make sense. I'll try to illustrate that in this presentation. So there's the two forward actuated flaps.
Using 7 Raptor engines.
Current contractors can't meet this objective, and we'll find ones that will. If American industry can provide critical commercial services without government development, then we'll buy them. If commercial rockets are the only way to get American astronauts to the moon in the next 5 years, then commercial rockets it will be. Urgency must be our watchword. Failure to achieve our goal to return an American astronaut to the moon in the next 5 years is not an option. As we will discuss today, this will require renewed focus and a relentless will to achieve our mission. And that's exactly what you have in abundance here in Northern Alabama. You know, urgency has always been in the DNA of Rocket City. Men and women in the Marshall Space Flight Center know exactly what it takes to be first. Be first in space because you've been doing it for generations. It was here you built the Jupiter C rocket that carried into orbit America's first satellite, Explorer 1. It was here you spent 15 grueling months executing over 200 tests of the Redstone rocket that launched America's first astronaut into space, Alan Shepard. Mercury 7, the Freedom 7 Mercury capsule. And it was here you answered the call of the nation, stunned the world. In less than 8 years, you built a rocket that carried the first man to the moon, the mighty Saturn V, that we see before us today. The hardworking men and women of Rocket City always embodied the American pioneering spirit. Restless energy, urgency, national pride, and impatience, anything less than the best. And
The reasons why it is important to go back to the moon: the water ice in the polar craters provide the essentials for life: food, water, and oxygen, rocket fuel for deep space exploration. These deep craters also provide protection from radiation and should help reinvigorate the American space program. But most importantly, these return missions can provide fundamental knowledge to solve lunar mysteries and understand the distribution of life in the universe. One of the great lunar mysteries are the lunar swirls. This is the Reiner gamma swirl, possibly formed by the interaction of solar wind with local magnetic fields. This is the mascon that was just discovered at the mass concentration, probably caused by a huge nickel-iron meteorite or asteroid slamming into the moon's surface at the South Pole Aitken Basin, where Shackleton Crater is located. 2.18 times 10 to the 18th kilogram, the mass of this metal body that penetrated into the moon's surface. Neil Armstrong said, "I think we're going to the moon because it's in the nature of the human being to face challenges. It's by the nature of his inner soul. We're required to do these things just as salmon swim upstream." And Wernher von Braun said, "Our sun is one of 100 billion stars in our galaxy. Our galaxy is one of billions of galaxies populating the universe. It would be the height of presumption to think that we are the only living things in that enormous immensity." So, in closing, the basic thing that is so important is to reinstill into the youth of America the kind of admiration we had for the great heroes of the American space program, the kind of knowledge that they will gain by becoming interested in science and engineering and mathematics, the kind of things that can help bring our country together. And in fact, we may find out that this mission may turn out to be a mechanism whereby the nations of the earth can reunite. right after the announcement was made by Vice President Pence, the very next day, the Chinese announced they were sending astronauts to the south pole of the moon. The next day, the Indians announced they were sending probes to the south pole of the moon. And ESA is planning missions to the south pole of the moon. So when I told this story a few weeks ago, a little girl about 8 years old looked up at me and says, "Does that mean we're in another space race?" And I said, "I sure as the heck hope so." Thank you very much.
3, 2, 1, 0. We have commitment. We have liftoff at 2:13.